So we like looking at objects when they're highest in the sky, when they culminate due south. And so that's why I've got the green line, which shows when an object is close to the green line, it's at its best viewing position. Now, it may not be its best viewing night because you might have something like a bright moon bothering you. So it turns out that for today's Insider's Guide, we have the waxing half moon just past first quarter moon. So it's not really the best night to be heading out and looking at some of these finest NGCs, which tend to be a bit more challenging than the brighter Messier objects. But definitely you want to make note of these and then maybe step out, try some of the brighter, couple of the brighter ones, but then, you know, wait for the moon to kind of clear out in a week or 10 days, and then you'll be able to tackle it at that time, tackle some of these at that time. So don't forget the, you know, sunsets happening later and later. So you want to grab these while you can. All right, let's see, here we go. So first up, I've got, and by the way, astronomical twilight at the latitude of Toronto. So the sky will get fully dark other than the moon at about 7:40 p.m. So really, you know, if you wait till 7:40 and beyond, then the sky will be as dark as it's going to be, except for the moon. All right, first up, we've got NGC 2194, which is here near the upraised club of Orion. This is a fairly rich open star cluster. And again, the default view in Stellarium, the plotting the stars on the screen, don't necessarily show you the true representation because, you know, oftentimes for star clusters, you need all the background stars to be visible as well. And Stellarium may not load in a deep enough catalog for you to see the richness of a cluster. So I recommend using the digital sky survey button that's in Stellarium, which I can click here. And that will actually load up the background sky so you can get a little bit of a better sense of it. So this cluster is pretty spread out, which lowers its brightness. It was discovered by William Herschel back on February 11th of 1784, and it was his type 6 object number 5 in his type 6 class. You might be able to see it in binoculars from a dark sky, but really any kind of a telescope will do the job. To find it, what I did is I star hopped. Let me just bring you back to the zoom where I can zoom out. I star hopped down from this Chi Orionis star, which is, so if you look at Orion's shoulder, you've got Betelgeuse, then you've got Mu, and then you've got the pair of Nu and Chi, where the club starts to spread out, and you're going to be looking down to the, you know, lower left of that or southeast of that. So what I did is I actually star hop from there. I can actually bring up a Telrad here. Let's see if I can do this again. I think I can bring up the Telrad. I do this. Didn't work. That's okay. So what I did is I actually star hop down from here. The other way you can do it is you can use your binoculars to look for these two stars, K and 73 Orionis. And I'll just bring up the symbols here so you can see where it is. And that's literally only, I believe, a degree or less than a degree. So it's a half a degree to the northwest of 73. So if you can see Chi in your binoculars, you can go down and see 73 and K, then you want to backtrack from them to the northwest and pick up the cluster. Let's see, when you're looking at it, I said you can also switch between Alhena and kind of Betelgeuse, or sorry, Alhena and Mu. So you sort of split the difference here and pick it up that way. But I think you can use these closer up stars. They'll do the job. So you want to look for its overall shape and size. Let me show you the simulated telescope view of it. This is a view at 64 power through a about a 6-inch Dobsonian telescope. If you want to look for its shape and size, the number of the stars, the density of the stars, any variation you might see in the star colors. It's about 10,000 light years away. While you're in the neighborhood, highly recommend that you nip on back up and check out the shopping cart or number 37 cluster. It's a brighter cluster, easy to find below and between the two club stars. That's number one. Next one up, we've got NGC 1931, which is the Fly. So if you joined us for our tour of Auriga a couple of weeks ago, I mentioned that in the lower part of the constellation, we had the Messier objects M37, 36, and 38 open clusters. And then we also had two medium prominent nebulas called the Spider and the Fly. So the NGC 1893 is the Spider with the letter Y and all this. Sorry, that's the letter Y. This is the Spider and the Fly here. This is the Spider and then the Fly. So if you make a triangle with M36 and 38, you'll find the Spider. And then if you just jog back a little bit towards M36, you'll pick up the Fly. So this is a fairly bright but small nebula. I believe it's a mix of reflection and emission nebulosity. You'll be able to see it in a smaller telescope, the central brighter core of it, but if you have a larger aperture and a darker sight, then you'll pick up a larger and larger view of it. Discovered by William Herschel back on February 4th, 1793, and it's his class 1, object 261. And some people have described this as a mini Orion nebula because it does have an interior star cluster that you can pick up through a smaller telescope, kind of like a mini trapezium cluster, the way Orion Nebula had. I've told you roughly where it is, so you can pick it up using these big bright Messier objects. You could also pick it up kind of looking at the corners of the constellation, Hassim and Elnath, and kind of splitting the difference and heading inwards into the ring of Auriga. Now, you probably don't want, you may or may not find filters help. So I think I found that filters didn't help very much because a filter, an oxygen 3 filter, for example, will dim the reflection nebulosity. It'll only keep the emission nebulosity. So you want to look for the stars inside. You want to look for any shape or form to the nebula that you can pick out. And again, while you're in the neighborhood, you might as well, I mean, at low power, you could practically get both of them in the same field of view. So you can look at the Spider and the Fly at the same time. This is about 8,000 light years away. All right, up next, we've got Thor's helmet, or the duck head nebula. And that's over here in sort of northeastern Canis Major. So you've got the bright star Sirius to get you started. When you're in the neighborhood, then you can actually head on over and pick up this. The way I find it is, let's see, I used a wide field eyepiece, and I star hopped starting from the star Mulefine or Gamma Canis Majoris. And you could also probably sort of eyeball it by using, let me just get this over here a little bit. Kind of taking that line from Nu2 through Gamma and not doubling the distance, but maybe a third of the way past them to pick it up that way to get yourself in the neighborhood. So this is a really a showpiece object. It's got a really cool shape to it. It's distinctive and interesting. You can see it in a 4 or 5 inch telescope without any real problems in a dark sky. And of course, anything bigger than that will show you even more. William Herschel spotted it on January 31st of 1785. It's object 21 of his class 5 objects. You want to probably look at it first with at say 35 power. So I'll just change this up to, why is this not letting me change eyepieces? Eyepieces, I'll switch to 26. So you can don't want to over magnify it. Once you've got it, then you can sort of zoom in and get some of the details inside it. UHC and O3 filters will brighten up parts of the nebula. So it might even change its shape when you do that. And you do want to look and see if you can see the energizing star in the middle of the nebula. It's actually a Wolf-Rayet star, a very energetic star, illuminating the object as well. And check out any of the field stars in the area as well. All right, next up we've got the Albino Butterfly Nebula. So this one's located kind of northern Puppis and kind of above Canis Major's back. It's a small planetary. It is within reach of most telescopes. Discovered by William Herschel on March 4th of 1790. It's number 64 of his class 4 objects. It's located 2.5 degrees northeast of Rho Puppis, which is the star Turis. And you can kind of find your way about halfway from that star to Molephane and kind of jog a little bit to the east to pick it up that way. What I did is I actually found M46 and M47 first, the open clusters, which are quite prominent here. And then I wound my way south by star hopping until I picked it up. So you can use an oxygen 3 filter to brighten this one up. Again, you will want to magnify it a lot more. So this is 64 times. You probably want to go to 100, and maybe even a little bit more if you have it. And that will allow you to see some of its cool and interesting structure. It's actually got a very lobate form to it. That gives it that butterfly name that it has as well. So you want to use averted vision to pick up some of the interior structures and note down its shape and orientation and things like that. It's about 4,400 light years away. And last up, we've got the dish cluster. This is NGC 2539. This is also in Puppis as well. It's kind of in an unremarkable part of the sky as far as stars go. It's a rich open cluster. Its benefit, though, is that it's quite close to the star 19 Puppis, which is a 4.7 magnitude. So you can pick that up probably naked eye or certainly with binoculars if you find your way there. And you can actually use, the stars of Monoceros and the top 2 stars of Puppis to get yourself in the neighborhood. This one was discovered by William Herschel back on January 31st, 1785. It's his number 11 of his class 7. You can see this one in binoculars in any size of a telescope. And as I said, use that star 19 Puppis to help you. And what I did is you can also aim your telescope 45 degrees of the way from Alphard. So if you find Alphard in Sirius, it's on that line, and you just need to go less than halfway from Alphard to Sirius and find it that way as well. So you want to notice its contrast against the background sky, any variance in the star colors. You want to maybe estimate how many stars you see and describe how the bright foreground star looks as well at the same time. So it's about 4,000 light years away. And that's it. That's it for today. Any questions on any of that? I'll just bring up a picture that shows where these all are.
Yeah, I think we've run out of questions.
That's okay.
You could always send us questions later if you think of something.
Absolutely.
I love Thor's helmet. That's a great one.
Yes. I caught that one late in the season. Just as the pandemic landed and places were shutting down, I took a drive out to the Forks of the Credit, which is east of Toronto, because I wanted a western sky. It was already well into the western sky when I went, and managed to get a good look at it with my my big Dobsonian, and yeah, really impressive, really a fun one.
Okay, someone's asking why not install Stellarium 1.2?
Well, one of the main reasons is that some of the star lore has been removed from version 1.2 due to disputes with copyright and that sort of thing. And
I'll tell you what, I uploaded it and it's still there. If you're uploading it new, brand new, never had it before, you won't get it. That's some of the First Nation stuff. But if you have had this for a while and you upload it, it's still there.
Okay, good to know. But otherwise, I don't have any reason not to go to the latest. So definitely go to the latest if you want to. I was worried I would lose that and I might need it. You also can, in theory, port it over. But if
You
you're saying
can.
that it remembers what you had and it just adds on, then you're fine.
There's a couple of Skylures that are in progress that haven't been uploaded yet, but you can get them from the wiki and plug them in. So
right. Well, you're the expert, Charles, so you should know. I trust you.
asterisks are my thing. What can I say?
right.
Someone is saying, can you show how Venus moves past Jupiter?
Oh yeah, good one to ask for. All right, let's go to now. There we go. Let's do this. Yeah, for those that will have clear skies, here's the sky tonight. And let's bring up this and just advance the time a little bit. So this has been a fun one. So these two have been approaching one another. You know, what's happening is that Jupiter is relatively slow moving. It's kind of moving with the background stars. Every night they drop by, I'll just wind back a few days here. The whole sky every night drops by about 4 minutes worth sunward. Meanwhile, Venus is swinging away from the sun in its orbit, and that's causing them to have a close conjunction on the 1st. So here's tonight, there's tomorrow night, and then they'll start to separate again. But you'll be able to pick them up. I think they'll share the field of view in a telescope eyepiece. If I bring up the markings for the telescope, markings. I'll just put a 1 degree in here and see what we get. There we go. So there's a 1 degree field of view green circle tonight. That's not even a very low power. And then if we go back to tonight, so if you use, say, a 1.5 degree eyepiece field of view, you should be able to put them both in the view at the same time. I think I recall that Jupiter's disk will be quite a bit larger than Venus's disk, but of course, Jupiter is something like 8 times farther away than Venus, but it's bigger. That's why its disk is still much larger. So yeah, that's what's going to happen. That's tonight, tomorrow, and then they'll start to separate. And we're going to lose Jupiter altogether within another week or two. So we're going to be done for the year for Jupiter. So we've lost Saturn, we're going to lose Jupiter. Neptune's already gone, it's down here. And within a couple of months, we're going to be bye-bye to Mars, and then Venus is going to be the only one in town for a while until August, I think, in the evening.
All
Great.
right.
Well, thanks everybody for tuning in. I hope you had a nice, enjoyed it. And Charles and I will do our best to keep the train running on time and on the tracks.
And I've
Back in a couple weeks.
recorded this, so I'm going to edit it and get it up on the channel so everybody can review it later.
Fantastic. So that the plan for next time is we're in March break period, at least in Ontario. I don't know how widely that is across Canada, but I thought I would just do something kind of basic and just talk about what you can see in the spring sky with your naked eye, binoculars, small telescope, kind of have fun with that. And then we'll do our final group of finest NGCs, and then we'll be jumping into spring.
Fabulous.
Thanks
Thanks, everybody.
Keep looking up.